Today we're going to start the conservation of energy topic. Now in this topic we will be looking at the everyday aspects of energy. This will cover the different ways energy is stored and transferred, how we reduce unwanted energy transfers, and we will learn about the different energy resources we use. In today's video we're going to look at the main energy stores, how energy is transferred from store to store, and how we represent this energy transfer using diagrams. But first we need to know what is meant by the conservation of energy. Now this is one of the key laws in physics, and this is that energy cannot be created or destroyed, it is transferred from one store to another. For example, you're watching this video on a computer. You can see what's on the screen because there is energy being transferred from your computer screen to your eyes by light. The screen is lit up because there is energy from a main supply being transferred to your screen by electricity. This energy from the main supply comes from a power station, and a power station generates electricity from fuels which contain chemical energy. So energy isn't created or destroyed, it is just transformed from one store to another. So now we're going to look at the 8 main energy stores. There is kinetic energy store. Now this is the energy of any moving object, for example a car driving down the road, someone running, planets orbiting the sun. So if something's moving, it has a kinetic energy store. The next is internal or thermal energy. Now if you look at an object and zoom in so you can see its particles, you're going to see that the particles are either moving around each other or vibrating depending on what type of material it is. Now if you add up the kinetic energy of each particle and the energy of the bonds connecting them, this will give you the total internal energy. Now every object, every solid, liquid and gas has internal energy. Then we have chemical energy. This is the energy stored in chemical bonds, and for some examples we can give for this is food, the energy in your muscles, or the energy in electrical cells which are in batteries. Now for number 4 we have gravitational potential energy. Now this is the energy of an object at height, so a helicopter in flight. If you walk up a hill you will gain gravitational potential energy. If you walk back down, you will lose this gravitational potential energy. Next is elastic potential energy. If you stretch or squash an object, it will store elastic potential energy. Some examples of this is stretching elastic bands, squashing or stretching springs, using catapults, and stuff along that line. Next we have magnetic energy stores. This is the energy stored when you push 2 repelling poles together, or if you try to pull apart 2 attractive poles. There is also electrostatic energy stores, which is the energy stored when you try pushing together 2 repelling charges, or again, trying to pull away 2 attracting charges. And finally, there is nuclear or atomic energy stores, and this is the energy stored in the nucleus of an atom. So now we're going to look at how this energy is transferred from store to store. So the first example we're going to look at is mechanical work. Now this is when energy is transferred because a force is moving an object through a distance. For example, pushing or pulling an object. Another example is sound travelling when ringing a bell. This is mechanical work. And an object falling due to the force of gravity pulling it down. Energy can also be transferred by electrical work. This is when charged particles move due to a potential difference. And this is exactly how energy is transferred in electrical circuits. Heating is another example of energy transfer, and this happens when there is a temperature difference, so when energy moves from a hotter object to a colder object, and this tends to happen through conduction or convection. And finally we have radiation. Now this is when energy is transferred by waves, or more specifically electromagnetic waves. So 2 examples of this comes from the sun. We can see the sun in the sky because the sun transfers energy through light. It also helps warm up our atmosphere because the sun transfers energy through infrared radiation. So now we need to show how we can show these energy transfers using diagrams, and there's 2 diagrams we're going to look at today. So the first one is the energy flow diagram, and this shows energy transfer using a flow chart. So if we think about a child going down a slide, at first, when the child's at the top of the slide, all the energy will be gravitational potential energy. Then as the child goes down the slide, they will gain kinetic energy. We represent this by drawing 2 boxes, one for the gravitational potential energy store and one for the kinetic energy store. Then we use an arrow to show the energy transferred. Now for this, the energy transferred by mechanical work done by the gravitational force pulling the child down. But some energy will be lost due to friction, so we need another arrow and another box. So the energy is transferred by mechanical work going against friction, so that's what we need the arrow for. And the other box we need is internal energy, because this energy is transferred into the internal energy store of the child and the slide. If we want to represent the amount of energy transferred, then we need to use a Sankey diagram. So we will look at the same situation of a child going down the slide, but this time we'll put numbers to it. Now remember, energy is measured in joules. So let's say at the top of the slide, the child has 1200 joules of gravitational potential energy. When he gets to the bottom of the slide, he will have 800 joules of energy stored as kinetic energy, and 400 joules of energy would have been lost due to friction. Notice that the energy at the start adds up to the energy in the kinetic energy store and the internal energy store. This is because energy is conserved. So to represent this, we draw a diagram which has two arrows coming off it, and the thickness of the arrows tells us how much energy goes into each store. So we need to make a scale. In this example, we will use a scale of 100 joules equals 1 centimetre. So the arrow needs to start off 12 centimetres thick. The arrow showing the kinetic energy store needs to be 8 centimetres thick, and the internal energy store arrow needs to be 4 centimetres thick. And this is how we show energy transfer using a Sankey diagram.